Hi everyone. In this live session, we're going to solve this equation, a very nice, excellent algebraic equation. We have x to the power of 7 plus x cube over x to the power of 6 plus x to the power of 4 equals 7 over 2. Are you able to solve this question? We have all x terms on left hand side and we have a fraction on right hand side. So how should we solve this? The first thing that we notice are the exponents. They are all high exponents. 7, 3, 6, 4. The highest is the 7 and the lowest is the 3. So what should we do? Our goal is to make all the exponents lower. So what should we do? Now 3, 4, 6 and 7. The number in the middle is 5. And so what can we do if the number in the middle, if you want to make the exponents to be lower, you should divide the numerator and denominator by x to the power of 5. Because 7 minus 5 is also 2. 5 minus 3 is also 2. 6 minus 5 is also equal to 5 minus 4, that is equal to 1. This is why we should divide the numerator and denominator both by x to the power of 5. So let's divide it. So we have x to the power of 7 over, now we're going to divide all of them by x to the power of 5 plus x cube over x to the power of 5, or we have x to the power of 6 over x to the power of 5, plus then we have x to the power of 4 divided by x to the power of 5, which is equal to now when you simplify, whenever you have same base and you have exponents, what do? You have x to the power of 7, x to the power of 5. Same base, there's division, you subtract the exponents. So what you get? 7 minus 5, you get x to the power of 2. Plus, here you have 3 minus 5. That's a negative exponent. So whenever you have negative exponent, what do? Whenever you have something like this, it's the reciprocal of that term. So you have 1 over x to the power of 3 minus 5 is negative 2. So reciprocal of that is 1 over x squared divided by, now this term, x to the power of 6 minus 5. You have x to the power of 1 plus 4 minus 5 is again negative 1. So you apply the reciprocal, that is 1 over x. Now this whole term is equal to 7 over 2. So I'm going to write that here. That is x squared plus 1 over x squared over x plus 1 by x is equal to 7 over 2. Now what are we going to do? After dividing, yes, it can be simplified further. Which formula you can use? If you think of the squaring, you can use a plus b the whole square. Now our new problem is what's the relation between the numerator and denominator. First let's use the identity. Which identity to get this? X plus 1 by x the whole square. If we use this, we're going to get the term in the numerator. We have x squared plus 1 by x squared plus 2, because x into 1 by x and x gets cancelled, so you're left with 2. So if you want only this term, this will be minus 2 on the left hand side. So you have x plus 1 by x the whole square minus 2 equals to x square plus 1 by x square. This is what you have. Now we are going to substitute this whole term in place of x square plus 1 by x square in the numerator. So we have x plus 1 by x the whole squared minus 2 over, we have x plus 1 by x plus 1 by x equals to 7 over 2. Alright. Now what can we do? What do you think we can do? So now we are going to substitute x plus 1 by x. You can see the same terms in numerator and denominator, x plus 1 by x plus 1 by x. So we are going to use substitution. Substitute this whole term. X plus 1 by x is equal to t. Now pay attention. What's the range of this t? It's always positive. We have to prove that. How it will always be positive, because look, if x is positive if x is positive, this equation holds and t is also positive. If x is 0, so if 0 goes into the denominator, this equation cannot hold. Now if x is negative, denominator is positive and numerator is negative in the main equation, if you check. So negative divided by positive is always negative. So x cannot be positive. Therefore, we cannot always t cannot be negative, x cannot be negative. Then t shouldn't be t should be positive. That's why t should be positive. So always t has to be greater than 0 because x has to be positive. If x is positive, t is positive. So now t square minus t, we're going to substitute that. T square minus 2 over t is equal to 7 over 2. Cross multiply, 2t square minus 4 equals to 7t. So we have to write that 2t square, bring it this side, minus 7t minus 4 equals to 0. Now you have a quadratic equation. How you can solve this quadratic equation? By using the factorization, by using cross rule. So let's see, we can have two factors, 1, 2, negative 4 and 1. Multiply 1 into 1, minus 4 times 2 is 8. 1 minus 8 is equal to negative 7, and that's your sum. So yes, we can use the factors. So what are our factors? I'm going to write that here. T minus 4 and 2t plus 1 equals to 0. That's what we got from here. So I'm going to write that. The first one, t minus 4 into 2t plus 1 equals to 0. Those are the two factors we've got. Now, how many cases are there? How many cases you can find? The first case, when t minus 4 is equal to 0, so you get t is equal to 4. But to find the value of x, let's substitute x plus 1 by x is equal to t, and that's equal to t. So x plus 1 by x is equal to t is 4. So let's substitute, and now you'll get again the quadratic equation. Multiply both sides by x, so you get x squared minus 4x plus 1 equals to 0. Now when you solve using the quadratic formula, you get x is equal to 2 plus or minus root 3. This is the value of x. Now the case 2, when you have 2t plus 1 equals to 0, t is equal to negative 1 divided by 2. So we need to write that t is equal to negative 1 over 2. So here it's negative, less than 0. So no real solutions. No solutions when t is negative. So this is the answer. Thanks for watching. Thanks for joining. And thank you for supporting always. Take care. Bye-bye.